In this lesson, we're going to look at distance time graphs again, but a wee bit more detail this time. So just a wee reminder, if we're looking at this journey here, this would be the journey of somebody going to a place. They'd be stopped because a horizontal line means rest, and then they would be coming back to where they started. Other points to note are that steeper lines mean faster travelling, okay, faster speeds. Okay, let's look at some questions to make you think before we go into some more detailed questions. So which of the graphs show that one runner started 10 metres ahead of the other? So your options are A or B, have a wee look, or C or D. So the question again, which of the graphs show that one runner started 10 metres ahead of the other one? So hopefully you answered D. You can see this person started 10 metres ahead of the other person. Okay, next question. In which of the graphs are the runners both going at the same speed? There's two questions here, I suppose. Which pair had the fastest runner? Right, so in which of the graphs are the runners both going at the same speed? A, B, C, or D? So if they were going at the same speed, then the lines must be the same steepness or must have the same gradient. Another way to look at it, they could be parallel lines, these ones here. So that is the one there, that the runners are going at the same speed. But there was another part. Which pair had the fastest runner? The fastest runner. So have a look. A, B, C, or D. Now to get the fastest runner, you should be looking for the steepest slope. So the steepest slope could be thought of in terms of triangles. So they're all going up to 4. So the highest, so that's 1, 2, 3, 4 high, 1, 2, 3, 4 high. I think this is clearly the steepest here. You probably just saw that. That's the steepest there. So it would be D. That's 1, 2, 3, 4, 5, 6 high. That. Okay, next question. Match descriptions with the graphs. Okay, so we've got 4 different graphs here and 4 different descriptions. So 1, the car is stopped. 2, the car is travelling at constant speed. 3, the speed of the car is decreasing. Or 4, the car is coming back. Right, the car is stopped. That should be easy to recognise. That looks like this one, doesn't it? The car is stopped. It's not going anywhere. The car is travelling at a constant speed. Should be just a straight line there. Car is travelling at a constant speed. 4 is easy as well. The car is coming back. So that would be the car is coming back. Okay. And that means the speed is decreasing. It's getting less steep, if you like. So that would be the last one there. Okay, last part in this section, I suppose. Albert, Bob and Charlie run a 100 metres race. Let's look at them. So they all run a 100 metres race. So I guess A stands for Albert, B stands for Bob, and C stands for Charlie. Who won the race? Well, the person that ran it in the fastest time, so that would be A, wouldn't it? Albert. Who stopped for a rest in a 100 metre race? Well, there's the rest there, isn't it? That would be C. Charlie must have got tired, stopped for a rest. How long did he stop for? Right, well, he stopped from 8 seconds to 12.5 seconds. That looks like 4.5 seconds he stopped for. Well, they're saying 5. I would probably say 4.5. It looks like 4.5 to me. How long did Bob take? Well, Bob, that's Bob there. So we look down. He took 14 seconds. How fast did Albert run? Well, he did 100 metres in 12 seconds. So if you do 100 divided by 12, you get 8.3 metres per second. Okay, right. Describe the differences in their running styles. I suppose A's running really fast, flat out, so is B. Charlie's having a wee rest in the middle. It's a strange running style for 100 metres. Right. Okay, so let's look at this idea, kind of things that are going to appear in your exercise. So if you look at this journey here, we've got to calculate speeds on the journey. So calculate the speed from A to B. So if you look from A to B, The distance is 80 kilometers, so you could write that down. And the time it took from 8 to 10, that's 2 hours. So to work out the speed for this particular part, just do distance over time, so that'd be 80 over 2, 40 kilometers per hour. You could also look at the return journey from C to D. So that's also 80 kilometers going from C down to D. And the starting point from that is 11 o'clock and it finishes at 12 o'clock. So the distance is 80 kilometers, but the time this time is just 1 hour. So again, you can do the same thing, speed equals distance over time, and you'll get 80 kilometers per hour. Remember, a steeper line means a faster speed. So if you think which one would be the fastest here, well, this one would be the fastest speed because it's the steepest slope. Okay, last example we're going to look at here, which is slightly different. You've got a line going up and a line coming back down the way. So this is 2 train journeys. One journey in the red going from Fort William to Inverness, and one in the blue going from Inverness back to Fort William. So the first question is, which is the slower train? So we're looking for the one that's less steep. That would be train A, or the blue that's less steep. Calculate both train speeds. So the red one, we have to get the distance, so it's 100 kilometers, and it took, what, 9.5 hours? So it's 100, sorry, 1.5 hours, not 9.5, 1.5 hours, so 67 miles per hour, and I've just rounded that to the nearest whole number. The blue one, it's travelling 100 kilometers as well. It should be kilometers per hour, by the way. It's travelling 100 kilometers, except it's taking 1 to 3 hours. So 100 divided by 3, again, that's 33.33 actually, but we'll just leave it to the nearest whole number. Again, I would probably change that to, we'll just change it now actually, 2 kilometers. While I do that, you could think of the last answer. At what time did they pass each other? So if you're thinking about what time they crossed or passed each other, you should be looking for this point here. This is where they crossed, and that happened at 9 o'clock. If you're looking down there, happened at 9 o'clock. That's where they passed. Now, if it was asking how far the red train, how far did they pass after, how many kilometers in its journey? Well, they passed, it was about 60, 70, about after 68 kilometers of its journey, and I suppose the other side would be, what would be 68, that'd be what, 22, 32, that'd be 32 kilometers into the blue journey. Okay, you should be able to try and access some of the questions in the exercise. Good luck with that.